Well, hello, this is going to be the final video for this week. These are the notes from Friday, April 27th. And it was an interesting day. If you were not with us in school today, we had a power failure, sort of right at the beginning of third period, or just as third period was starting. And that kind of threw a wrench into a whole lot of stuff. So I managed to do some of these notes by sunlight that kind of crept through the windows. And I did it on that little board that I normally put assignments on, so, well, whatever. So the top part of these notes kind of refer to a warm-up. There it is. And they want us to write the first 6 rows of Pascal's triangle. All right, no problem. There's the first, there's the second, there's the third, fourth, fifth, sixth. You probably ought to have that committed to memory. And then it wants us to use the triangle to expand this. Well, it's just going to be x to the fourth would be this row here. That is your fourth. So it'll be 1 times x, and that'll be to the fourth, times y to the 0, plus 4 x to the third, y to the first, plus 6 x squared y squared, plus 4 x to the first, y to the third, plus 1 y to the fourth. And just to get rid of all the extra nonsense here, it'll be x to the fourth plus 4 x to the third y, plus 6 x squared y squared, plus 4 x y to the third, plus y to the fourth. All right, easy enough. Probably could have done that without listing all of this, but I wanted to do that just to make a point about your binomial theorem, which shows up here. And remember that we're dealing with a situation where we really are trying to avoid Pascal's triangle. We are just trying to pick certain terms, and like for example down here, if you're picking the 7th term from a grand total of 16 of them, you really don't want to build that Pascal's triangle, you know, that far and write out all the terms and pick out the 7th one. It's just like way too much. So we're going to use the binomial theorem, and this is what we kind of saw yesterday. This is combinations, one way of saying it. Another way is to say n choose r, or n objects, we're choosing r at a time. And that corresponds perfectly to the values in Pascal's triangle. Then we have the first thing in our binomial, the first term in the binomial, like up here. And it's not always an x. It might be like down here, a 7a or so, whatever. It'll be to the n minus r power, and n will be the number of your exponent on your binomial expansion. So here n would be 15. And then y to the r. We actually are going to pick r based on the term. So for example, if we're asked to find the 4th term, then r will be 1 less. So this will be the r plus 1th term, and that equals 4. Subtract 1 from 4, and so r equals 3. And the reason that r is 1 behind the number of the terms is because of this. Up here, when we start, r is 0, not 1. And that's in your first term. Then it goes to 1 in your second term, and then 2 in your third term, then 3 in your fourth term. So you see how it lags 1 behind every time? That is why when we look for the 4th term, it's actually going to create this r value being 1 less than that. All right, so hopefully that will stick with you, and we'll just go ahead and expand what we've got here. So we want to find the 7th term. So r plus 1 equals 7, or r equals 6. That answers that question. So, and this is going to be n right here. So we can set up our combinations. So that'll be the first part. All of these, picking out the various terms or specific terms of binomial expansion has three parts. You have the combinations part, which is just another way to represent values from Pascal's triangle. Then you have the first term, or what we were calling x, and that's to the n minus r. Then you have the second term, which we were calling y, and that's just going to be to the r power. So here's how you put it together. N is 15, so it's 15, choose, r is 6. All right, that'll generate a number. And then we have 7a, and that'll be to the 15 minus 6 power. And then times 2b, and if it's a minus 2b, bring the negative with it, and that'll be to the r power, which is 6. So when you do this in your calculator, you just type in a 15, then you go to probability, pick NCR, hit enter, then put a 6, hit enter, and out pops 5,005. So there are actually 5,005 ways to pick 6 objects from a set of 15. That's a lot. So this will then be 7a, 15 minus 6 is 9, and then 2b to the 6th. And you notice that those two add up to 15, which is n. So now it's just a matter of cranking out the number. That's going to go in the field that I just put down there, and it'll give you a term that'll end a to the 9th and b to the 6th. We just need the number to put in here, and it's going to be big because this will be 64. I don't even know what 7 to the 9th is, but 64 times that times 5,005, it comes out to something in scientific notation. It's so big. So 1.293 times 10 to the 13th power. This is acceptable. It is to 3 places of accuracy at least, and yeah, that's the answer. Okay, so for letter B, they've changed it up a little bit. They want you to find the b to the 3rd term. Well, this is going to be r, all right, because when you have a and you have b, well, the b comes second. See, a and b comes second. So if it's the b to the 3rd term, then that is the exponent that determines the r. So which term is it? It's just going to be 3r plus 1 equals r, so that will equal 4. It's the 4th term. And what is r? We already said it was 3. So we should be good to go. N is 11, so we can kind of record that. And let's go ahead and do this. So this will be 11, choose 3, right? 11 things taken 3 at a time, times 2a, and we'll raise that to the 11 minus 3 power, and then minus or negative 3b, remember the sign goes with it, to the r power, well, that's just 3, right? So you do this first in your calculator, and you get 165, and that'll be times 2a raised to the 8th power times negative 3b, and that'll be raised to the 3rd power. So whatever we get here, the sign will be negative, because positive, positive, you're cubing a negative, that'll give you a negative here, and it turns out it is 1, 1, 4, 0, 4, 8, 0. All right, that is your coefficient, a to the 8th and b to the 3rd. So this is how this is accomplished, and you just have to make sure that you get the process down. About the only thing that can kind of mess you up is if you have like something like a square here, and you're supposed to find some kind of term. It's just going to complicate things. You're going to have to sort of think your way through it. So I'm going to load up the next page. So stand by while I do that. So back we are, and we're going to kind of do a little bit of a repetition of what we did yesterday. The only difference when we expand these binomials is that we have some oddities here, like rational exponents, imaginary portions, but let's just go for it. Now, if you expand this thing using the coefficients from Pascal's triangle, you may recall it's 1, 5, 10, 10, 5, and 1. This is great, but I am going to throw in the notation for combinations. That's something that is kind of important, but you know, it works either way. So starting this out, we're going to start out with 5 things taken none at a time, and that'll be, this is your first term, a to the 3/5, and that'll be raised to the 5th power, times 2 raised to the 0 power. Okay, how many ways can you pick nothing from 5 objects? Well, that can only happen one way, you just don't do it. This is one, so basically it's just a to the product of these two exponents, so this will be a to the 3rd. That's the cleanest, nicest term we're going to get. So let's go on to the next one. This will be 5 things taken one at a time, times a to the 3/5, and we'll raise that to the 4th power, and then times 2 raised to the 1st. All right, how many ways can you pick one thing from 5 objects? That will be 5 ways. Times 2 is 10. And miraculously, that matches, let's see, 1, 5, something's not right. 5, 1, 5, 10, 10, 5, 1. 5 things, 5, oh, 5 times 2. Stand by. I'm just having a little bit of a brain issue. Let me pause for a second. Okay, duh, it is 1, 5, and the next one will be 10. It's just that this piece is going to increase it even more. So, I'm awake. So let's fill in the rest. This will be 10a to the 12/5. Strange exponent, but we'll continue. So the next thing will be combination 5 things taken 2 at a time, and that'll be times a to the 3/5 raised to the 3rd, and then that'll be 2 squared. So if you do this on your calculator, it should be 10. There's 10 ways to pick 2 things from a group of 5, and 10 times 4 should give us 40. So plus 40. And then we'll figure out the exponent. Isn't that 9/5? Okay. So then we'll go on. Now we'll do 5 things taken 3 at a time. And that'll be a to the 3/5 raised to the 2nd power, and then 2 raised to the 3rd power. I'm out of room, so I'll continue up here later. If you do this again in your calculator, you should get another 10, and this will be 8. So the next coefficient will be 80, and that'll be a to the 6/5, all right? So let's see. Up here, we'll do plus, continuing. This will be 5 things taken 4 at a time, and there's only 5 ways to do that, so there's your 5. And then a to the 3/5, and that'll be dropping down to the 1st power times 2 to the 4th. So that's going to be 5 times 16, which is 80, a to the 3/5 power. And then your last one will be 5 things taken 5 at a time. There's only one way that can happen. And then that'll be a to the 3/5 raised to the 0 power, so that's 1. And then times 2 raised to the 5th power. So I think everything here just 1, 1, and then 32. So that's plus 32. So there's your expansion, even with rational exponents. So let's look on at B. And this will be a little more complicated with the I term here. So I don't have you here to check up on my mistakes. I always seem to stumble on this one, but we'll give it a go and we'll hope for the best. So this is going to be to the 4th power, and I'm not going to do the combination notation on it. So just go to Pascal's triangle, 1, 4, 6, 4, 1, right? 5 terms for an exponent of 4. And with this imaginary portion, remember, I equals square root -1, right? So if we start looking at how exponents, you may recall that I to the 1st is just the square root of -1, which is I. And then I to the 2nd is just this squared, which is -1. And then I to the 3rd is just going to be -1 times another 1, so that'll be -I. And then I to the 4th is just going to be I squared squared, which will be 1. So remember this? I1, I1. And if you keep going to the 5th term, the whole pattern just keeps repeating. So let's give it a go, see what we get. So your first coefficient is 1. That'll be times 5 raised to the 4th power. And this will be negative radical 3i to the 0 power. Thankfully, that makes it easy. So 1 times 1, and this will be 5 squared times 5 squared, which is 25 times 25, or 625. So good start. But it was the easiest term, so let's try again. Then our next coefficient is a 4, right, the second one. And this will be times 5 raised to the 3rd, and then times negative radical 3i to the 1st. All right, so this is going to be 125, and 125 times 4, just let me make sure, 125 times 4 is 500. All right, so this piece of it right here equals 500. And it's just going to be times everything that's in here, because anything to a 1st power is just itself. So you will get a negative term out of it. So it's negative 500 radical 3i. So 2 down, 5 to go. So let's try the next one. So this will be plus 6 times 5 squared times negative radical 3i squared. All right, for starters, this is going to be -1 when you square this, but it will also be the opposite. So I'm a little concerned I'll get the sign right on this one, but let's give it a go. So this will be 25 times 6. That should be 125. It's just that right there. And this will then be, if you square this, this goes positive. And if you square that, that becomes a 3. But if you square this, this becomes -1, right? I squared is -1. So this will be 125 times -3, which should be -450. Okay, good, got that far. So then we're going back down, up 4 to 6, and then back down to 4. So it's 4 times 5 to the 1st times negative radical 3i, and that'll be raised to the 3rd power. All right, this part of it should be 20. Okay, and if we cube this right here, won't we get -3 root 3? And then if you cube I, that's just going to be -I. So it'll be times -I. So what do we get? This will be negative times negative is a positive. So that should be 60 root 3i. Right? Again, this is 20. This will be negative times negative, which will make it positive. 3 times 20 is 60. and you have the root 3, and you have your now positive I. So we have one more term to do, and I think I'll just do it down here. This will be plus 1 times 5 to the 0 power, and times negative root 3i raised to the 4th power. Right? This is 1, this is 1. If you raise this to the 4th power, that goes plus. So your term over here will be plus. And I to the 4th is going to equal 1. So that's done. So we just need radical 3 raised to the 4th. Well, isn't that going to be like 3 times 3? So that should be plus 9. Wow. Okay. So we have some common terms. These are like terms. And those will add up to 184. And then these are like terms also. And so that'll be minus 440i. So yes, that is your answer. And you know, the expansion was the easy part. It was dealing with I that was a little maddening. So finalizing the rest of this. Now this is where we're going to make a connection to calculus, because your difference quotient will be heavily used when you start next year. And so why not throw it in here? If we're going to use x to the 4th for f of x, we're just going to expand it a little bit by including h. So we'll start out with x plus h raised to the 4th. All right, that'll be this part of it, minus f of x, which will be x to the 4th, and that'll be all over h. So all you need to do is expand this, and knowing how to do that from the sense of a binomial expansion is really useful. So again, raising to the 4th power, it's a Pascal's row 1, 4, 6, 4, 1. Okay, so here goes. We're going to get x to the 4th plus, let's see, 4x to the 3rd y plus 6 x squared y squared plus 4x y to the 3rd plus y to the 4th. And don't forget this guy, so minus x to the 4th. And that's all over h. And if you note, we have a positive x to the 4th and a negative x to the 4th, which just leaves these terms left over. And guess what? I put in y's when I meant to have it be h's. Let's just pretend these are all h's here. My bad. All right. And right. So let's go ahead and cancel. So we'll get 4x to the 3rd, right? Because that'll take out that h, plus 6x squared h. You'll get one of the two, plus 4xh squared plus h to the 3rd. And that is what it is. Okay? So sorry, I'm so used to x's and y's that forgot I was dealing with h's here. But anyway, there's your notes for Friday, and please check the announcements on Canvas for some resources from our quiz that we took that was so wildly successful, and for some changes in our tutoring for next week, which will benefit both our tests on series and sequences and our tests for retesting logs and exponentials. So have a wonderful weekend, and until next week.